Hello folks, hope you're all well. Here we are again. So here's a song that you may have watched on my YouTube before. I'm not sure if I've sung it to some of you, maybe I have. You can see it on YouTube if you like, but it's just the main chorus that's very important that you'll remember from year 12 vectors when earlier this year when you did them with Carrie Ann. It's just singing this formula, A dot B, and then divided by the mod of A and next the mod of B. Now invert the cos just because it was the angle that we wanted in degrees, etc. Right. Anyway, you can listen to the more tuneful or not more tuneful song on YouTube. So we'll move on. Here are two questions. If you use that rule that we've just seen, you should be able to answer these. So find the angle between the vectors A and B. So it's that A dot B, and then divided by the mod of A and next the mod of B. Then invert the cos just because it was the angle that we wanted in degrees. So you do that. Then with this one, it says the position of the 3 points A, B and C are given like this. So that's a funny IJK, what do we call that? Component form, if you remember. If you make them column vectors, if you prefer, so you could change that and just write them all down as I'll just change one for you. So A equals 3, 2, minus 3. And so you put B and C. Then you've got to find the angle between AB and BAC. So you have to actually calculate that vector and that vector. And then those two vectors are what you do, put in the A dot B and then divided by the mod of A and next the mod of B. Then invert the cos just because it was the angle that we wanted in degrees, etc. That's to be fine. Have a go. So pause the video now and then we'll have the answers. So if you've done the first one, 18 degrees. If you take the mod, you make sure you get the acute. On the second one, say calculate AB and AC, and then you just put those in the formula, and out comes 70.5 degrees. Wow, let's hope you got those. Okay, today, lesson 5. We've got to be able to find the angle between a line and a plane, and then find the angle between two planes. And of course, what we've just been doing is recapping scalar product. You'll see it comes into today's lesson. So the angle between a line and a plane. Let us consider a plane. That's a flat surface. There he is. Wow, yellow. A line with vector equation r equals a plus lambda b. So b is a direction vector, a is a point on the vector line. So there's our vector line. The dotted line is trying to show how it comes through in 3D, so it actually comes out here. You can see that sort of, it's very weird. The angle theta between the line and the plane is there. The vector n, if you remember n from last week or even the week before, is the, if you remember this word, perpendicular vector to the plane. So there he is. I know it doesn't look perpendicular, but the angle's on it there, meant to be. We can easily find alpha. Where's alpha? Well, alpha, there's alpha. You can easily find that one, but not as easy find that one. But hopefully you can see, if we can find alpha there, and this is just a right angle triangle, so all you have to do is because that's 90, all you have to do is 90 take away alpha, and then you get theta. So we can easily find the angle alpha between the line R and the vector perpendicular to the plane, which is n. Just noting there that in the line, vector line B is the direction vector of R. Right, if we after this angle here, it's just the scale of the product, the angle between two vectors. But it's B dot n and then divided by the mod of B and next the mod of n. Now invert the cos just because it was the angle that we wanted in degrees. So, and then as I said, to get theta, all you have to do is 90 minus alpha, and that will get you theta. So let's have a see. Here's a question. Right, find the angle between the line and the plane. So let's just remind ourselves of the equations here. So this thing is a plane. It's in the form, let me see if I can write on here, R dot n, so that's your perpendicular vector to the plane, equals A dot n. So we know that A dot n ended up as 6. And R, if you remember R, was just general point x, y, z. So n must be 3 minus 5, 1. Ooh. And here's your equation of your line. That's the vector A, so that's a point, just a point on the line, and that's the direction vector. So we need to get alpha first. So in order to get alpha, we're going to have to just write out n. Our vector n, so that's the one that's perpendicular to the plane, is 3 minus 5 and a 1. The other vector we need from the line is our b vector, and that is 3, 0, minus 1. So our alpha there will be A dot b, so it's n dot this. So 3 times 3 is 9. We're going to, in a minute, we're going to have to do cos to the minus 1, aren't we? Because I'm after an acute angle, I shall mod whatever we get. So dotting these two, you get 9 plus 0 take 1 over the mod of that, so that's a bit of Pythagoras, square and square root, so 9 plus 25 plus 1 makes 35, root 35, times root 9 plus 0 plus 1, 10. If you do that on your calculator, you'll end up with, I think, 64.68 degrees. And this just means, hence, we've got our theta, which is the angle between the plane and the line. There's a line. You can't really, we haven't got a plane on this picture, but you just imagine it's like a flat surface somewhere. So you've got 90 minus 64.68. Ooh, no, don't do that. 8, there's the point. Degrees if you want on those. And that comes out at 25.3 degrees to 1 decimal place. Oops, that's the end popping up there. Super. Right, you have a go at these. Very similar. This first one, there you are, you've got, this is a plane. No, it's not, that's a load of old rubbish. That's the line, isn't it? Of course it's a line. There's the direction vector, and that's just a point on it. And this is the plane. What you'll have to do here, it's like saying x, y, z dot r. And that's your normal equals your A dot n. So that's in the plane form, and I think you'll probably see that. I don't tell you, but 2 minus 1, 4. Yeah, that goes there, and that will be your n. So that's another n there. That's just your r dot n. So you'll get your n from that. So you use your b here, and you'll be able to do what I've just done. On this one, oh, this is a little teaser. The line's been given in that form. So it's not the vector form, it's like that Cartesian form. So what you have to do, you have to let lambda equal x plus 1 over 3. You have to let lambda equals y minus 2, etc. And lambda equals that other thing. And then you end up finding what x is. X ends up as minus 1 plus 3 lambda. And the y is, and then z is, and then you put it in more like that sort of form, vector form. And then you've got your vector equation of a line that links to the direction, if you remember, and that's the point on the thing. Don't really want to spoil it for you, should I? I'll leave you to do z, and then you'll have r equals minus 1, 2, and whatever that other one is, plus lambda and 3 minus 1, and whatever the z works out as. I'll leave you with that. And then you're back in, there's your b. On the plane, oh, this looks fun. How is it given this one? Well, it's given it in vector form. So that's like r equals or plane pi. The plane equals that thing. So that's just a point on it. That's one direction, and that's the other direction on the plane. If you remember how you find your n from this, your n vector is the direction cross product, not dot product, this one, this direction here. So you have to cross product these two. You can do that on your calculator if you remember how to find it. So cross product those two, and that gives you your n. So have a go. Sorry, that's like hard to see where the plane and the lines. So it's line, plane, that's one question. Line, plane, another question. And then, so pause it and have a go. It's not too bad. Hopefully you've paused now. Right. Hopefully you've unpaused. Here come the answers. That's the first one. So alpha worked out at 44.19, which means that theta's 45.81. Pause if you need to have a look. And then next. So I changed all that, and that ended up as your direction vector. And there's the plane, cross product of those two. You got that one, and then you use that one, and the B one, and you use the formula. And I think, am I adding the question, or is more of the answer? There's more of the answer, yeah. So that's your B, that's your N. Do the business with N, gives you the alpha, and then you take it away from 90 to get the theta, which was the angle between the line and the plane. Hope you managed. Okay, that's that finished. So that's that aim done. Now we're going to do the angle between two planes. Let us consider two planes. It's not aeroplanes, they're just flat surfaces. Oh. And the acute angle between them, theta. And there's our two planes, and there's our acute angle between the two planes. If you imagine this yellow plane would carry on underneath this other plane, so that would be the angle between them. It doesn't just stop there. We don't want that big obtuse one. We want this one. The vector n1, which is, no surprise here, perpendicular to one of the planes a vector n2 is perpendicular to the other plane. Right, oops here. The acute angle between the two planes is, let's have a look, see here. Right, that's our angle that's just been hired. That's the angle alpha that we're at, theta that we're after. If that's theta and this is 180 degrees, that must mean that that angle there is 180 minus theta, or pi minus theta, which is 180 degrees. If that's that, and then we've got like a quadrilateral here, haven't we? No, quadrilaterals, four-sided shapes, 1, 2, 3, 4. The angles in there add up to 360. Now these two are 90s, so that's 180 now. So these two have to add up to 90. So that means that that angle at the top here, this angle here must also be theta. Magic. So the acute angle between the two planes is equal to the angle between their respective perpendicular vectors. So if we can find the angle between n1 and n2, what we've actually found is the acute angle between the two planes. Fantastic. That got you excited. So all we have to do here is use our scalar product formula with n1 and n2 in. It's even easier than the other question. And a flashy box to show it off. Right, so let's have a go at the question. So our n1 and n2, let's write those down. Remember, this is like r dot n equals a dot n. That's the equation of a plane, one way of writing it, isn't it? So our n1, we're going to call 1, 2, minus 5. Line it because it's a vector. And our n2, we're going to call it 2, minus 1, 2. Ignore the rest. Right, so nice and easy, following the formula. Yeah, then I don't go completely wrong if it just said it's nice and easy. So theta equals cos to the minus 1 of n1 dot n2. So 1 times 2 is 2, plus 2 times minus 1, plus 5 times minus 5 times 2, minus 10. And then mod of that one, 1 plus 4 plus 25 makes 30. Times mod of that one, 4 plus 1 plus 4 makes, yeah. You mod it to get an acute angle. So that minus 10, you just treat it as a plus 10. And stick it in and it'll give you an acute angle. And the acute angle this time is 52.5 degrees. Feel free to check it. Okay. I think there's one for you now. Well, two for you. So here's a similar ideas. Plane and plane. We've talked about the first one, how you find it, and talked about the second one. So like your R, that's in form R dot N, remember. So you just have to pull out the N as, call R as X, Y, Z. It's obviously been dotted with 1, minus 1, 2. And you only need that, don't you? And this one, to find the N, the other N, put it in 2 if you like, you'll have to cross product those two vectors. These two are just in the form R dot N. They're nice, aren't they? Right, pause the video and have a go. It says do it on big whiteboards. I don't think that means do it on your walls in your bedroom, but who knows? Enjoy. Okay, hopefully you're now unpaused, and warning if you haven't, here come the answers. Ta-da! If you did mods round that, you'd have got 82 straight away, but never mind. And 73.2. Hoped it worked for you. Okay, well, that's about quite a short lesson today, isn't it? Ooh, right, so you're going to be doing exercise 5D, page 102, questions 1 to 7, with extension questions 8 and 9. But maybe before you go, you want to try this little gem. It's an old exam question. It says, here is a cuboid. Edges are parallel, obviously. And F has coordinate 5, 2, 4. Show -2, 5, 0 is perpendicular to both OB and OD. There's something to think about. And B, it is given that is perpendicular to the plane. Find the angle between the plane. Bap, bam, bap. Well, I'll leave you to have a think about those. And when you're ready, you can unpause and have a look at the answer. If you're still struggling before I let you look at the answer, you needed a bit of a hint and then want to pause again. I think like telling you, giving you F here means that O to B, because there's the origin. That means if you know F is that thing, that must be the X movement. So B is also 5 in the X. It is also 2 in the Y, but it hasn't gone along. So it's a 0 there. And then you've basically got to dot that with this and see if you dot them together, if you remember dots, not cross, if you dot two vectors together, then they're perpendicular. You can work out OD again using F as your helper and dot those together and see if they give you 0, and if they do, then they're perpendicular. Pause again if you need. Okay, hopefully you've unpaused now, and here come the answers. Okay, and here's the answers. So there we have it. There was, I told you it was OB, and then that's the other one. Got them together and giving you 0. And then when you're after the angle between the planes, then those two, and so on, like we've just been doing today. There's the acute angle, there's the obtuse. Super, right, so you've got that exercise to do. Hope that keeps you off the streets. Not that you're on the streets, but there we go. Okay, see you next time.